Hello everyone. So today we shall see some operations on set. See, operations on set in the sense, we are having two numbers, say 2 and 3. If we are having two numbers, we know we can add two numbers, we can subtract, we can multiply two numbers, and we can do division with some conditions, right? So we can do some operations if we have two numbers. Like that, instead of numbers, we are having two sets now. So if we are having two sets, what kind of operations we can make between the sets? That is what we are going to see. Fine. So the first operation what we are going to see is called union of two sets. Say A has elements 1, 2, 3, and B is another set, it has an elements say x, y, right? Now A and B are two non-empty sets. Yes, they are non-empty because they have some elements, so it is called non-empty. Now with these two sets, we can introduce one operation that is called A union B. With these two sets, by doing some operation, that is union operation, we are creating another new set that is called A union B. What is called A union B? A union B means it's a collection of all the elements. To avoid the confusion, this x and that x, let me use another notation. It's a collection of all the elements such that that element should belong to A, or, note the word or, that element is from the set B. So you put all the elements in this set, which can be either from A or it can be from B. Or in the sense means, here it is called inclusive or. I don't want to go in deep. Just you put all the elements of A and put all the elements from B. That's all. That is called A union B. So this is 1, 2, 3, x, y. That's all, right? Your element of A union B, it could be come from either A or it could be come from B, right? This is called A union B. What is called intersection? Yes, just it's a collection of all the elements such that that element should be in A and that element should be from B, right? You can put some elements inside the set A intersection B when that element should be from A and B, which means you can collect the elements in A intersection B which are common for both A and B. You can take the elements, if it present in both A and B, only you can include that element in A intersection B. So what kind of elements we can have here? Here no element is common between A and B. So A intersection B is what is called here in this case? That is empty set. Empty set, which means this is nothing. Inside this set I am looking for some element. I can include some element here only if that element present in both the set. I am searching for the element which present in both the sets. There is no such element. So there is no elements here. But the set is here. Inside the set, I couldn't find any element. So this is empty set. Suppose if I change my set like this, it has x, y and also 3. So for this question, what is our A intersection B? 1, 2, x, y? No. But 3 present in both the sets. So I can write 3. Yes, 3 is the only element which is present in both the set, right? So A intersection B is equal to 3 in this case. Fine. So what is the difference of two sets? Difference of two sets means it is like a say A minus B, collect some elements, right? That element should from A, but that should not belong to the set B. We have to collect the elements from A, but check that if that element is present in B, don't write that element here. If that does not belong to B, you can write that element. For example, 1 belong to A, but 1 does not belong to B. So I can write 1 here. 2 belong to A, 2 does not belong to B. So I can write this. 3 belong to A, but 3 also belong to B. So I should not write the element, because go back and revise that the number or the element which satisfy these conditions only which can be presented, right? 3 does not satisfy these conditions. If 3 satisfy this, fails to satisfy this. So in total 3 does not satisfy these conditions. So we can't write 3 inside. Fine. Okay. Okay, what is called complement? See, complement means we can refer it with the universal set. What is the universal set? Universal set varies, depends on our situation, depends on our problem. For in this case, let me consider my universal set is going to be set of all natural numbers. I consider my universal set is set of all natural numbers. Of course, A is a subset of U. Now I have to collect, I have to go for A complement. A complement means it is a take the universal set and subtract A from universal set. A complement means subtract your set A from the universal set. The remaining is going to be your A complement. Subtract it. So what are the elements? This has all 1, 2, 3 and so on, right? So what are the elements will be presented here? 1 here, 1 here. So we should not write here. 2 here, 2 here. We should not write. So the remaining is going to be 4, 5 and the remaining. Fine. Thank you.